In today's manufacturing world, well, it feels like a constant race, doesn't it? From the first idea to the finished product. If you're not running at absolute peak efficiency, you're basically falling behind. But the real trick, the big challenge, isn't just about being fast, is how do you get that speed, that agility into these really complex, traditionally quite slow workflows, specifically thinking about that whole design to build pipeline. And crucially, how do you do it without things going badly wrong, without major errors? So that's precisely what we're going to unpack today. We're doing a deep dive into how artificial intelligence, AI, is shaking up that pipeline. We'll focus on two spots that are, let's be honest, often slow, very manual, and yeah, pretty prone to errors, generating bills of materials, bombs automatically, and that whole strategic dance of kicking suppliers.
And it's really important to understand this isn't just, a small tweak. The sources we looked at are clear. This is a massive shift, a seismic change, really. We're seeing AI systems that are fundamentally changing the production timeline itself.
Mm.
I mean, think about this. Some early data suggests that just by automating these specific jobs, companies are cutting down the time they spend on that initial bomb check by like 80%. And they're seeing real drops in sourcing mistakes, sometimes within the first few months. So it's about getting projects done faster, yes, but also improving the financial outcome for every product.
Okay, right. Let's break that down then, starting with what you call the foundation piece, the bill of materials. You
Yeah.
described it as the literal backbone of any product design. So that massive list, sometimes thousands of items long, right? Every single part, material, even the nuts and bolts needed.
That's exactly it. And traditionally, building and managing that BOM, that's where good designs often get stuck in the mud. It takes incredibly careful, almost clerical work, translating what the engineers design into a list you can actually use for ordering and building. And as products get more complex, the manual work just explodes, which, well, it inevitably leads to human mistakes, parts getting missed, different versions causing chaos. Seriously, one single wrong part number in that BOM, it can bring an entire assembly line to a halt.
Okay, so this is where the AI really makes a difference. The sources say these tools can now generate bombs automatically with, and this is the key phrase, minimal human input on ad. So the big question is, how? How does the machine actually create that list without someone sitting there reading the blueprint?
Well, it uses very specialized machine learning algorithms, ML. These AI systems, they're trained on enormous amounts of data. We're talking millions of old BOMs, technical drawings, material specs, even regulatory rules. They essentially learn the patterns, the connections between shapes, materials, and the components you need.
So when engineers finish a new design, what's the AI actually reading?
It takes in the complex design files themselves, mostly the computer-aided design, or CAD drawings. You can think of a CAD drawing as like the product's digital blueprint.
Yep.
It has all the 3D shapes and related info. The ML algorithm doesn't just, look at the file. It rapidly goes through the geometry, recognizing shapes and features. So if it sees a hole that's specified for, say, an M6 bolt, the AI doesn't need a person to manually add that bolt to the list. It automatically figures out the item needed, the exact material, how many, and the correct part numbers.
Right, that level of identification, connecting a feature on a drawing to an actual component you need to buy, that must be where the huge time savings come from.
Absolutely. And that really hits our first core benefit here, improved efficiency. By automating this whole process, you're shaving off days, maybe even weeks, of that initial planning and checking. It frees up engineering teams. They can focus more on designing better products, on innovation, instead of, mind-numbing data entry.
Okay, hang on though. If the AI learns from old data, how smart is it, really? What happens if there's a totally new custom part in the design? Something with no history in the bombs it trained on? Or maybe when you need to substitute a material that feels like something a human needs to decide.
That's a really good question, and it touches on how sophisticated these modern AI systems are. It's not just simple pattern matching anymore. It uses predictive modeling. So if the design includes, say, a new type of alloy or custom-made plastic part, the AI looks at the functional needs. Things like stress tolerance, heat resistance, the required precision. It can then flag that parts as custom, maybe give it a temporary internal number, and even suggest similar commercially available parts if the design allows for substitutes.
Ah, okay. So it can handle novelty to some extent.
Exactly. And that capability leads us straight into the second key advantage, enhanced accuracy. Because the AI is pulling the BBAM information directly from the digital design data, those CAD files, it guarantees consistency. It cuts out the risk of someone mistyping a number or missing a detail. And an accurate BOM means less wasted material. You stop buying the wrong components, which is painful, and you prevent expensive rework later on during production. It's all about making sure the digital plan perfectly matches what you actually intend to build.
Okay, so once you've got this super accurate AI-generated bomb, the game shifts, right? Now it's about sourcing. The bomb tells us what we need, but getting the project done right now totally depends on who supplies it and how fast.
Precisely. And this is where AI steps up from just managing lists to being a real strategic tool. Picking the right supplier is tricky. You're balancing cost, quality, delivery speed, reliability. It's complex. Traditionally, sourcing might rely on old relationships or maybe getting quotes manually, which takes ages. AI helps cut through all that guesswork. It lets businesses make sourcing decisions based purely on data.
So what exactly are these systems looking at? We know the obvious things like price and how long it takes to get the part, but what makes the AI suggestions more strategic?
Well, the core is usually those key performance metrics, or KPIs. Things like price, yeah, but also their proven quality record, their guaranteed lead times, and, this is important, their past performance working with your company. But the real intelligence is in how the AI weighs these factors. For instance, if your inventory for a part is running dangerously low, the AI might prioritize a supplier who costs a bit more but has a verified shorter lead time. It understands that avoiding downtime might be worth more than saving a couple of percent on the material cost right then. And beyond that, these tools mix your own historical data, how supplier A performed for you last year, with real-time external information. They track global material prices, check commodity availability, even look at shipping lane issues to recommend the best supplier for each specific part right now.
That makes a lot of sense. Finding the most strategic fit, not just the lowest bidder. But what about the really big, unpredictable stuff, like political instability somewhere or a natural disaster hitting a supplier region? And how do you stop the AI just always picking the same top supplier, leading to vendor lock-in?
Yeah, those are critical points, and that's where the truly strategic factors are considered. These modern AI sourcing platforms are built to actively manage and mitigate risk. They look way beyond just, did they deliver on time last month? They evaluate broader things: the supplier's geographic location, the political or economic stability of that area, their main shipping routes, their known production capacity. They often use predictive risk models to actually score suppliers based on these external factors.
Okay, so they try to anticipate problems.
Right. And about the vendor lock-in issue, the algorithms are usually set up to encourage supplier diversity. They might have rules like sourcing critical parts from different geographical zones, or ensuring that a certain amount of business gets rotated among other approved alternative suppliers. This stops you becoming too dependent on just one source and builds in some resilience.
Right. This powerful combination, the accurate BILM upfront, and then this smart risk-aware sourcing seems to drive the last two big benefits mentioned in the sources. Let's talk money. The third key advantage is cost reduction.
Oh, absolutely. And the cost savings come from several places. First, the AI helps pick the optimal supplier, getting the best possible terms based on current market conditions. That's direct savings. Second, by catching those bill of materials errors early, you slash the need for rework, cut down on wasted materials, and avoid those really crippling costs that come from production delays when parts are wrong or missing. It's about getting really precise cost control over the whole project.
And the final point, which maybe it's a bit surprising when we talk about automation taking over tasks, is about the human element. The fourth benefit mentioned is better supplier relationships.
Yeah, it seems like a paradox, doesn't it?
Yeah.
Data-driven systems improving relationships. But by using objective performance data and risk information, companies can move beyond just haggling over price. The AI provides clear, consistent, transparent views of how well a supplier is actually doing, delivering on time, meeting quality specs, hitting cost targets. And that shared data lets you have much more informed, strategic discussions. Instead of arguing about pennies, you can talk with your best suppliers about long-term partnerships, planning future capacity together, maybe even joint R&D. The data actually builds trust.
So when you pull all this together, the takeaway seems pretty clear, doesn't it? AI isn't just another tool to make things a bit faster. It's fundamentally changing the core ways manufacturing gets done. It's bringing measurable efficiency, accuracy, and cost savings to areas that, honestly, were stuck in slow, manual processes for decades.
And the sources strongly suggest this shift isn't really optional anymore, at least not for companies that want to lead. Adopting these AI solutions for bombs and sourcing, it's becoming essential for businesses trying to streamline how they work, manage increasingly complex global risks, and basically future-proof their entire design-to-build process. Especially in today's market, which is just getting more volatile and competitive, it's really the difference between just keeping up and actually setting the pace.
Which leads us to a final thought for you, our listener, to consider. Given how much more complex products are becoming, how much we now rely on instant real-time data for accuracy and cost, and how vital it is to manage global supply chain risks, if AI truly becomes essential just to stay competitive, what happens to the businesses that stick with the old ways? The ones relying solely on traditional manual methods for bombs and sourcing in the years ahead? It seems like those manual systems won't just be slower, they might actually become incapable of competing at all. Something to think about.